So good evening, good evening. I am, like I said, I am back on a regular basis. I will be here on Mondays from now on. Just to let you know, if you've been tuning in, my father is getting much better. But how can I help you this evening?
All right. That's wonderful, Mr. Tinsley. Again, I am so thankful and prayerful for your dad and
Thank you.
family. I have been working on the algebraic expressions. Now, a little
Okay.
disappointed in myself, because
On the new
out of
site, right?
yes, on Canvas, yes, sir. Now it's been graded, but I looked at that and some of them are like basically kind of obvious, like common sense wise to see. But my problem is that when it's more than two numbers, I get confused because it could be like a 4n with an x by it plus 7e, stuff like that. So I'm kind of everywhere.
All right. So
And when I
let's
seen
let
the
me let
grade,
me
I was
open
like,
that up and look at it because what you
okay.
remember is those keywords. So you say you're looking for certain things. Let's see. Mistakes. And on Canvas, right?
Hmm.
I don't see it.
You gonna see it?
Mm-mm.
They sent me an email say that was already graded, and it showed me like what I had.
It's crazy because I see a grade at the end. That
Mm.
means I would need to see a grade on. Is that it? Let's see. There we go. I see it. All right, let's go. I see it. Let me open it up. So I'm gonna have to go to preview and to tell me which one it is. You said algebraic expressions, right? So let's look at it. So you how many questions are there? There are
It was
10.
a low.
So you
Uh,
got 8 right. So that's pretty good. So to me, you pretty much mastered it. Okay, so 15 less than twice a number, right? So right here, twice a number is
you sure
multiplication.
this one mine, Professor Tinsley?
Hmm?
You sure this one mine?
Hold on. That's the only grade I see under algebraic expressions. You never seen
Oh,
this question? No, this question is just the test in general.
oh, okay, okay.
So 15 less than twice a number. So remember, please excuse my dear Aunt Sally. This is multiplication, twice a number. Well, we don't know what the number is. 15 less than. Okay. So 15 less than. So less than is what? What operation?
Subtraction.
Subtraction. So is it 15 minus 2n or is it 2n minus 15?
Mm, well, the way it's read, is it 15 minus 2n?
So remember, so if I said 15 less than 20, what would you say?
15 less than 20. That'll be negative, wait, five.
If I just said the words 15 less than 20, how you doing, Kenya?
Hello.
15 less than 20. So 15 less. So if I got 20 and I take 15 less, I got 5 left. So what happens is the numbers are reversed. So it's twice. So that's why it's 2n minus 15.
Okay,
So a
got
lot
you.
of times the language. So that's why if you do enough, you'll get used to the language. Right? So for
Right.
example, the next one says, and I haven't even looked at these in so long. 3 times a number. Remember, times is multiplication, increased is addition. So this is multiplication. So 3 times a number. We don't know what that number is. Increased by 17. Got me?
Got you.
Okay, so that's how you look at the problem. So let's see if we can find a little bit more difficult problem and understand because algebraic expressions, you're probably gonna have 2 to 3. So you're gonna have to evaluate algebraic expressions, and then you're gonna have 1 or 2 explicit algebraic expressions where you got to change those words to an algebraic expression. So this is why I made this quiz because you're going to have at least 2 of these. Here you go, right here. 16 times the sum of 3 and b. So 6 times, that's multiplication. The sum is addition.
Mm-hmm.
So it's telling you the sum of 3 and b. So you're doing that together. The only way we know how to put something together is parentheses. 6 times outside those parentheses. So if you notice, I put many different options on it to see if you really understood. Sum is addition. Difference is subtraction. The product of is multiplication. The quantity of is parentheses. That means whatever that quantity of is in that parentheses. So there's certain words you look for in algebraic expressions. And what I'll do is I'll send that along with this video and the screenshots. I'll send a word handout that lets you know the key words to look for, like all together. Sum is addition.
Okay.
Less than, difference is subtraction. You know what I mean?
Right.
So those are
Thank you.
important. And you only gonna have 2 of those. So it's not like you're
Okay.
gonna have a whole lot. Okay?
Got you.
All right, what's next? What's next? So again, this thing is just I'm working on it on the fly. So I tried to include everything you need from beginning to end. So no matter what level you start on, you should be able to move through this course and do well. So from whole numbers all the way through system of equations and measurements and quadratic equations. Then I have all the different the ones with the greens you can see. But then I have all the practice GED exams right there. Okay, so the key thing is when what I would do is either the GED ready or the practice exams that I have. Take one, see how you do. So say for example, algebraic expressions or tables, charts, and graphs, whatever you need to work on, you then go to that section and work on those till you got them. Remember, the key thing that I think people don't understand is in school we are taught if you know something well, right, it's 80 or above because 80 is good, right?
Right.
So what we're thinking, so that's why I consider mastery like 80%, even though total mastery would be 100. I consider mastery like 80%. If you score 75, 80% or above, you can go on to the next section because this is what you got to remember. To pass the GED math exam, you only need 58%. So you only need basically a little less than 6 out of every 10. So out of those 40 questions, you need about 24. If you know that going in, it helps you alleviate some of the stress. So some of those difficult problems that you're spending so much time on and wasting so much time, you can say, well, listen, you know what? I'm not even gonna worry about that problem. I'm gonna skip it. Because I got problems. I got problems with that. But you know what? I'm gonna basically work on this. So what I would say is, I would say all the way down to percents is your basic pre-algebra work. So whole numbers, fractions, decimals, percents, ratio, and proportions. Okay. Anything that involves letters replacing numbers is algebra. So area and perimeter is algebra. So make sure you know your exponent says volume is algebra. Mean and median and range are guaranteed on your exam. So if there's anything, so what I'd like to do in this course, these are all the concepts and the types of problems you're expected to see. So when we talk about word problems, let's look at some word problems because I'm just going to pick any practice GED exam. Let's just find a word problem and see if we can find it and how to break it down. Because I think that's the problems a lot of people have. But what also you're having is go through a problem, work at it. Okay, let's look at this one. Now, unfortunately, I can't make it so big because it doesn't work like Schoolage. You see, okay, that's not too bad. Oops, what just happened? It was big there for a minute and then it got little. See, all right, so right there. So when you look at this problem, in a scale drawing, a 42-foot tree is drawn 6 inches high. The flagpole next to it is drawn 7 inches high. How tall is the actual flagpole? Like, where do you even start with this problem? How do you know what to do with this question? Is it Pythagorean theorem? Like, what type of problem is this? Because but this is what I want you to remember. There are key words that you're looking for. When I see that word scale, it's ratio and proportion. That's what scale is. It's a ratio using ratios and proportions. Did you know this was a ratio and proportion problem? Why? It's because you got to have a conceptual understanding of the math. When they compare two numbers together for whatever reason, right? That's a ratio. That's what a ratio is. So the ratio that they're giving you is that for every 6 inches, it's 42 feet. So for every 6 inches, it's 42 feet. Well, I need to know what 7 inches are. Where did my 7 inches go? Remember, I got inches on the top over here. I got feet on the bottom. This is the ratio I know. 6 inches is 42 feet because they gave it to us. That was given. But they want to know what's the actual size of something with the shadow or drawn 7 inches high. Not shadow, but 7 inches high. So that's the unknown. So we're going to give it X. You can call it anything. So how do we solve a proportion? You can use equivalent fractions. Well, what do I have to multiply 6 by to get 7? There's no whole number that I can multiply 6 by to get 7. So we're not going to use equivalent fractions. Unit rate. I could use unit rate, but my lower number is on the top. So for right now, we're going to skip unit rate. The third way I explain how to solve a proportion, there's 3 ways you should know how to solve a proportion. Equivalent fractions, unit rate, and cross multiplication. So I'm going to cross multiply whatever that has my variable first, because I want my variable on the left. It's just much easier. That's how we learn. That's how we learn algebra, with the variable on the left. But anyway, so 6 times x is 6x. 42 times 7, again, I'm going to use mental math. So 40 times 7 is 280. 2 times 7 is 14, so that's 294. Understand what I did? Again, the more you can do mental math, the better you're going to be at math. So 42 is 40 plus 2. So 40 times 7, 7 times 4 is 28. Multiply by power of 10, bring down my 0. 2 times 7 is 14. I add those together to get 294. So how many times now? To get x by itself, we need to do what? Divide by 6. 6 go into 29 4 times. You got 24 left over. So 6 go into 24. 6 times 4 is 24. You got 5 left over. Bring down that 4. You got 54. 6 goes into 54 9 times. Okay, so that's using cross multiplication. You could also say, okay, 42 feet for every 6 inches. Well, 6, so that means if I reduce that to lowest terms, I get 6 goes into 42 7 times. So for every 7 feet is 1 inch. So if I know every inch is 7 feet, 7 times 7 is 49. Still got the same answer. That's solving by unit rate. Okay, so again, with these practice tests is it gives you the types of problems you may see. So when you do them enough, you'll be able to identify. You might not be able to do all these word problems one by one. Okay, this is a word problem with an algebraic expression. On Tuesday, $D worth of merchandise was sold. On Wednesday, the merchandise sold was sold. Let's do what it says first. Identify your givens. D dollars worth of merchandise was sold on Tuesday. So Tuesday, D dollars. On Wednesday, the amount of merchandise sold was 150 less than twice the amount of merchandise sold on Tuesday. So Wednesday is 2 times the amount sold on Tuesday. Well, Tuesday is D, and 150 less than that. Which expression represents the amount sold on Wednesday? There we go. So again, this is an algebraic expression, but in a more involved word problem.
All right.
But you gotta use those key words. Twice the amount is multiplication. 150 less is subtraction. It didn't say 100. It didn't say twice the amount from, or twice the amount less than. It said 150 less than. So that's why that minus 150. Got me?
No, I see it now.
Okay.
Okay.
And the more you practice, Like, now this, okay. To me, I would tell you to use the calculator, because this is not going to be one of your first 5. But you will have a radical or radicals on your exam. You will have radicals on your exam. The beauty of radicals on the GED exam is that you have your calculator. You don't have to worry about any of them. No matter what radical they give you, you're going to be able to put in your calculator. But let me show you how you would do it. Again, there has to be some type of knowledge of why you're doing it before you just go grab the calculator, right? So what happens is, even though I'm giving you shortcuts using the calculator, you have to have some conceptual understanding of when to use what, right? So watch this. So if I'm using the calculator, watch this. Second, x squared, 80, enter. I'm done, 5 seconds. If I need to know the decimal equivalent, hit the double arrows, 8.94. So if they ask you to answer, to simplify as a radical, 4 square root of 5. They tell you what the decimal equivalent is. Again, you can use your calculator. But how would you do this by hand? Okay, so because if you have a conceptual understanding, then when you use the calculator, it make a lot more sense. Watch this. So remember, I told you I want you to know all your squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. You should know all your squares up to 15 for this GED exam. You should. Because if you know the squares, you know the square root of each number. And I'm going to show you how. Because what did I tell you? Math is about patterns. Okay? So I'm going to change my color to red, and I'm going to do my square roots. The square root of 1 is 1. The square root of 4 is 2. You should now see the pattern. The square root of 9 is what?
3.
3. The square root of 16 is what?
4.
So if you know your squares, you know your square roots. Now watch this. This is what I'm going to do. Remember, the first thing I told you, if you were in my class, is you should know your multiplication tables. You should be able to do 100 multiplication problems in 5 minutes. You should know your multiplication tables down. 9 times 8, 72. 6 times 3, 18. 8 times 7, 56. You should be that fast. It shouldn't be 6 times 3, 6 times 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. You shouldn't be doing that. So the first thing I would tell anybody to do in math is 2 things. Know your numbers that make 10. 1, 9, 2, 8, 3, 7, 6, 4, 5, 5. And know your multiplication tables. Why? Because most people that have problems in math is because of division. Guess what? Decimals are divisions. Ratios are division. Proportions are division and multiplication. Right?
Right.
Probability is fractions, which is division. So, but guess what? The opposite of multiplication is division. So if I know 9 times 5 is 45, so if I know, watch this, if I know 9 times 5 is 45, because Mr. Tinsley told me, make sure I know my multiplication tables, watch what happens when I go inverse or I go the opposite way. 45 divided by 5 is
No.
Stop playing. That's why knowing your multiplication tables is so important. People say, Mr. Tiz, yeah. No, listen, I'm telling you, anybody I tutor, I don't care if they're elementary, high school, or collegiate level. The first thing I do on the first night, I give them multiplication tables. I give them 100 problems in 5 minutes. And most of my college students in my high school say, oh, that's so easy. Okay. So when we go to ratios, we go to proportions, we go to Pythagorean theorem, when we go to simplifying radicals, because watch this, watch what happens when you simplify radicals. So I'm looking at my squares and I'm looking for the highest perfect square that goes into 80. So 1 times 80 is 80. 4 times 20 is 80. 9 times nothing will give me 80. 6 times 5 will give me 80. So square root of 16 times the square root of 5. Well, we know the square root of 16 is 4. 4 square root of 5. I just figured out my radical that easy by knowing my multiplication tables. Because I know my multiplication tables, I know my squares. And because I know my squares, I know the inverse operation of squaring something is square root. So now, because of my multiplication tables, I know my squares, my square roots, and I know how to simplify radical. But it has to start somewhere. It has to start with a certain understanding and a certain speed that you have to do. And what that is mental math. It's certain things in math you need to be able to do in your head. Not saying you can't use the calculator, but if you're in a test and you're doubting yourself whether you know what 9 times 6 is, what happens when concepts get harder? Then you don't have that same self-esteem. So again, I showed you on how to do it on the calculator, showed you how to do it by hand. The square root of 80 is 4 square root of 5. And you're gonna need radicals or squares and square roots for the first 5. You're gonna need square roots for Pythagorean theorem. And you're gonna need square roots for distance between 2 points. Okay. So again, they're going to help you. Let me make this small. See if I can make it small. See, this is thing. Okay, watch this. Again, this is another problem. There's certain skills you need on your math exam, your reading exam, or
You
your
sound a
speech math
little
exam.
bit low, Mr. Tinsley.
Can you hear me now?
Right, there it is. Okay.
I said there's certain concepts that you need on every exam. Being able to analyze tables, charts, and graphs. You're going to need on your math exam, your science exam, your social studies exam, your reading exam. The first thing we're going to do when you see a chart, you look at the title. The first thing I want you to look at before you read the question, before you read the paragraph, the title. Percent employed by age group and educational attainment 2012. Then I want you to look at the x-axis, and then I want you to look at the y-axis. Mr. Tenzia, x-axis, the coordinate plane. Yes, what you remember is the horizontal axis. You're doing a graph. It doesn't matter. Is your x-axis. The vertical axis, no matter what you're talking about, is your y-axis. So what does this mean? Second thing, so we looked at the title. We looked at the two axes. So we look at the axes. The x-axis is my age groups. My y-axis is what the numbers, right? But how do we know what those numbers mean? We look at what's called the legend. Okay. So we see this light pink is less than high school completion. Percent employed. So what this means is in the ages 20 to 24, 48% that have less than high school completion are employed. Now, as you obtain your GED and high school completion, the employment rate goes up to 64. Some college, no bachelor's degree, goes up to 75%. And having a bachelor's degree or higher, being employed is 87%. So what this tells you is that the highest the more you attain education, the better employment chances you have, your better employment probability. So if you understand that, looking at one age group, you understand the only difference is they talk about a second age group, 25 to 34, and then a third age group. But what we notice is, what do we know about patterns? Patterns. As we get more education, the employment goes up. So knowing that, let's look at the question. Okay, so let me save it. Let me clear it. Oops, let me save it. Let me clear it. And let's see, based on the graph, how much more likely is someone age 30 to be employed if he has a GED compared to not having a high school? So I specifically either found this question or used this question because this is the purpose of getting a GED. You will notice right away your employment probabilities will increase. So let's look at it. Age 30. So I am looking at the first group? No. Am I looking at the second group? Yes. Because the age 30 is between 25 and 34. Am I looking at 35 to 64? No. So I'm looking in one area. Second thing, what are they giving me? How much more likely is someone age 30 to be employed if he has a GED compared to not having a high school degree? So we look at our legend. Less than high school completion is that pink. High school completion, including GED, is white. So 69%, 56%. So how much more likely is somebody? 69 minus 56 is 13% more likely. Okay. This is a skill, tables, charts, and graph, that you will see on every single exam. This is one of the most important areas for your GED, not just math, but science, social studies, and reading. You will have tables, charts, and graphs. So, um, in my course, make sure I got the same answer twice. I got to see how I make mistakes. 13% more
Mm-hmm.
likely I got there twice. So remember, I've been trying to get this out. So I'm gonna have to fix that before. Matter of fact, you know what? I'm going to fix this right now before I get. I'm going to practice GED 9. We're going to do this right now.
I've never seen a graph broke down like that before.
Right. So again, and that's what you want to do. So I have a section just for tables, charts, and graphs. Let me tell you something. So I had a young lady. Um, was it one, two? Today is well, damn, it's been that long. This was in October. She failed the science exam 6 times. So I looked at her last test and I said, listen, we're going to go over independent, dependent variables and how to analyze tables, charts, and also showed her probability or Punnett squares in science. She
Mm-hmm.
had failed 6 times previously. She said, Mrs. Tinsley, I've been studying for about a month and a half, 6 weeks, since my last time I failed, because I had to wait 60 days. So she had to wait one more week. She said, well, we only went over those little things. Why do you think that I failed 6 times and we're going over these little things that you think I'm going to pass? I said, because if you look at tables, charts, and graphs, even though it's one concept, you miss 4 questions that had to do with tables, charts, and graphs. With your Punnett square, you missed 2 questions. That's 6 total questions. And then independent and dependent variable, you missed 3 questions. So total, out of those 3 concepts, you missed over 10 questions. So what we're going to do is we're going to focus on those areas. We focus on those areas. She took that test that next week and passed.
Mm-hmm.
So my point to you is that you don't have to study every single thing. But what you do have to study is what I tried to put in this course. Everything that you need to be able to pass the exam. Okay. So here,
Yeah.
this example came up, or example like this came up, and the young lady did not know how to do this problem. She said, Mr. Tinsley, like I've been studying And I know how to do a one-step problem. 2x equals 4. Divide both sides by 2. Cancel the 2's, x equals 2. She said, Mr. Tinsley, I know how to do a two-step problem. Subtract 3 from both sides. 2x equals 4. Divide by 2 on both sides. X equals 2. Mr. Tinsley, I know how to do, if I had, you got to use distributive property. 2x plus 3, 6 equals 10. Subtract 6. 2x equals 4. Divide both sides by 2. X equals 2. Okay. She says, I know how to do all that, Mr. Tinsley. I've been working, I've been doing this math. But when I see a problem like this, I have no idea what to do. I said, the reason why you have no idea how to do it is because you're trying to remember it. Every skill that you just showed me is in this problem. So the first of all, what you got to remember is multiplication comes first. So I got to do my distributive property. 2 times 2x is 4x. 2 times minus 5 is minus 10. Equal. This is combining like terms. Okay. Addition and subtraction. Go left to right. So I'm going to add first. 3x plus x is 4x minus 2x. 4x, now I'm going to go down. 4x minus 10 equal 2x. But the key thing you forgot is you can have variables on both sides of the equal. You just have to combine like terms. Here, you combine like terms. You changed all that to 2x. But you still can combine like terms on opposite sides of the equal sign by doing the opposite operation. So here, I don't divide by 2 because I'm trying to get x by itself. I'm trying to move this 2x to the other side. So if I subtract 2x from this side, I subtract 2x from this side. So I get 2x minus 10 equals 0 because 2x minus 2x is 0. Now this becomes a two-step algebraic equation. Add 10 to both sides. 2x equals 10. X is not by itself. The opposite of multiplication is division. So I'm divide by 2. Whatever I do on one side, I do on the other. So I divide the other side of the equal by 2. These two cancel because 2 divided by 2 is 1. 1 times x is x. X equals 5. She said, Mr. Tinsley, stop playing. Right? So this is why, right? I always say in my classes when I'm helping my students, stop playing. Because what she discovered is about math is once you understand math, have a conceptual understanding, you can combine the concepts to solve mathematical problems because now she wasn't scared. So just by showing her that and saying, stop playing to her, she went and took her exam and she went from failing her exam to college ready in 2 weeks. Because the biggest thing, I'm telling you, 2 things. Your confidence and self-esteem comes from once you understand a problem, understand a mathematical concept. Now you practice enough easy, medium, and hard questions. You push yourself. So because what happens is when you're on my GED course or you're in class, when you get to a hard problem, you try, and then you give up. You stop. But guess what? In real life, you don't do that. When they cut your electric off, you figure out how to get that electric back on. You get fired from your job, you find another job. So the fortitude that you must have is you have to prove to yourself that this difficult math problem I can figure out. Because once you figure that math problem out that you thought you couldn't solve and you solve it, what you do is give yourself confidence. You boost your self-esteem. Okay. I literally had a young lady who took the high set exam. She took the high set exam 7 times. Her highest score was 4. She took it one more time and she got a 2. She came to my class, and by the time she finished my class was 8 weeks. She went from a low score of a 1. She got a 1. She got a 2. The highest score she had a 4. She got 19 out of 20. Went to community college of Philadelphia. Got accepted in a community college. Tested out of the algebra class and said, Mr. Tinsley, I love math. I'm going to probably pick a math major. She made Dean's List, graduated, got her associate's degree, and now she's in for a bachelor's degree. Again, these are things because what happens is, I teach math not because of the concepts, because so many people have problems with the concepts. Because I want to prove to people something that defeated you will no longer defeat you. So when you take that to real life and you say, you know what? There's nothing that I can fail at that I can't conquer. There's nothing that you can give me that I can't do, because all I need is put the hard work and somebody needs to show. Now let's look at this problem. We have several concepts here. We have the multiplying monomials. So you got one term and one term. 4 times 2 is 8. X times Y is XY. Put them in alphabetical. Plus, now I'm going to use this as one term, plus 3Y. 3Y times 2 is a positive 6Y. 3Y, a positive 3y times a minus X is a minus 3, because remember, when you don't see a coefficient, that number is 1. So this is a minus 1. Minus 1 times 3 is a minus 3. Y times X is XY. Okay? Remember I told you, math is about patterns. You see a pattern. You got 2 terms that have XY. These are called like terms. So we just look at the coefficient. 8 minus 3 is 5. So 5XY. And then we're going to bring down the plus 6Y. Plus 6Y. We're done. Which is answer A. But what happens is a lot of people like to skip. Oh, I got to figure out slope. But if you don't know the distributive property, if you don't know combining like terms, if you don't know your exponent rules, as algebra and those problems get harder, then you have difficulty, and then you start getting mad at yourself. You start questioning yourself. That's the worst thing you can do. There's nothing on this earth that you can't figure out. Nothing. I don't care if it's rocket science. If somebody show you how to do it and understand, now it might take you longer. Doesn't mean you can't get it. I had a student the other day. I was tutoring in calculus. Right? I hadn't had calculus in 30 years. She said, "Can you help me?" I said, "Well, I haven't done calculus in years. Let me see it." Looked at it, didn't know how to do it. Briefed through how to do it. Oh, I got it. Explained it to her, and she said, "Mr. Tinsley, you telling me you didn't know how to do this problem? You haven't had calculus in 30 years, and you explained it better than my teacher." She went to school the next day and explained to all her classmates, not all class, all her friends. All her friends got 90 or above on that quiz. The teacher came to them and thought they were cheating. Let me explain something to you, not just about math, but about life. When you prove to yourself that you can do something that you thought you couldn't do, it opens up the horizons. It proves something deep down inside you to say, there's nothing, because I love my children, right? So there's nothing that I can't learn. Why? Because I want to make sure my children get the best that I can give. And once you prove it to yourself, now you prove it at work. And then you show somebody else. And then you surround yourself around those positive thinking people. Next thing you know, you're in a whole different circle of friends. You know how I know? Because many people have called me up and said, "How did you teach me math, but you changed my life?" Because I started looking at things differently. I started surrounding myself around people that said I can do and not I can't do. I started not spending my time around those people. And I started spending time telling myself I can do. And then I started doing. Then I started doing more. This is why I teach this class and go over these class for free. I don't do that. I don't get paid because I've helped over 250 people pass their GED exam. This is not a group. This is not a company. It's just me. And I've helped over 250 people pass their GED exam. But more importantly to that, I showed them that they can do something they couldn't do before. Let's look at this problem here. How many people know how to do this problem here? And this is a problem you're probably going to see. It's called, and you want to use the exponent rules. How many people can do this problem? So if I asked you to simplify this problem, would you give an answer A, B, C, or D? Or I'm going to make an E, IDK. I have no idea, Mr. Tinsley. What would you say that answer is?
Oh. Take a while. D.
You said D? Okay. How about you, Kenya? A, B, C, D, or I have no idea. I don't know.
I don't know.
And guess what? There's nothing wrong with I don't know. How about you?
I think B.
B. Okay, let's look at it. So remember, simplifying, right? So if I had 6/2, you want to know how many times you want to find the greatest common factor. So the greatest common factor is 2. So what do you mean by greatest common factor, Mr. Tinsley? What numbers can I multiply together to get 6? 1 times 6, 2 times 3. So my factors for 6 are 1, 2, 3, and 6. What 2 numbers can I multiply to get 2? 1 times 2. But what is the greatest common factor? So greatest means the highest, common means the same. So when I look at this, what is the greatest common factor? 2. What happens is you probably not knew how to do this problem, but you didn't know you were using greatest common factor. Because that's the conceptual understanding. So when numbers get bigger or you get exponent, you got to use these same concepts. So 2 goes into 6 3 times, 2 go into 2 1 time. This simplifies the 3. That's how you do this problem. But here, what if I had this? 10 plus 6 divided by 2. Having a conceptual understanding means I know when I'm dividing by 2, that means I have every term divided by 2. So really, this is 10 divided by 2 plus 6 divided by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. 5 plus 3 is 8. Or, combining like terms, 16 divided by 2 is 8. But I showed you this so you can understand how to simplify that expression. Now, why is it expression, not an equation? Because an equation must have an equal sign. So let's go solve this expression. So 36 x to the 4th over 12x to the 4th plus 12x to the 8th over 12x to the 4th. So just like that simple example, in this hard example, I showed you the same concept. So now we know how to do 36 divided by 12. Well, 12 goes into 12 1 time. 12 goes into 36 3 times. Okay, what's the second thing we need to know? Anything over itself cancels each other out. What do you mean by that, Mr. Tinsley? 5 divided by 5 is 1. 8 divided by 8 is 1. X divided by X is 1. X squared divided by X squared is 1. 2x squared divided by 2x squared is 1. So what we did was we transferred what we know from a young child to algebra. Anything divided by itself is 1. So they cancel each other out. So this leaves me 3 over 1, which is just 3. So I go to my second. 12x to the 8th over 12x to the 4th. Again, 12 divided by 12, or 12 goes into 12 1 time. 12 goes into 12 1 time. X to the 8th divided by x to the 4th We need to know our exponent. We need to know that if I'm dividing exponents with the same base, I need to subtract the exponents, top minus bottom. So I look at this exponent is 8 minus 4, which is 4. So my answer is x to the 4. The second thing we should know is a 1 in front of my expression, I don't need it. Dividing by 1, I don't need it. So now 3 plus x to the 4th. Now, again, my associative property tells me it does not matter what order I add in. So 3 plus x to the 4th is the same as x to the 4th plus 3. Stop playing. So this difficult problem that I'm telling you, exponent rules are one of your first 5 questions you need to be ready for.
Exponent rules.
Exponent rules. Do y'all know the exponent?
Yeah, I got some notes on it. I was looking at notes this morning on it.
Well, let's make sure we know, because that's what we do. This is what you're here for. If you don't know, ask that question. Don't be scared to ask any question at all. I don't care how difficult. I don't care what the problem is. I don't care if you had it in class, because I found out the other day, a student is going to an adult education class, and her teacher went over a couple problems, and was totally wrong on every question. She went back to class, explained she said, my tutor, I said, my tutor said you were doing these incorrectly, showed him, privately, not in front of the class, but privately. He then had to do the lesson. So everybody makes mistakes. Okay, so exponent rules. One of your first 5 must know your exponent rules. So I call this the first 5. The first 5 are the questions that you cannot use the TI-30XS calculator. So what are the first 5? So multiplying and dividing decimals, mixed to improper fractions, and vice versa. So I'm going to draw 2 arrows. Undefined, the distance between 2 numbers on a number line. I should have probably typed these out because my handwriting is on a number line, which is another way to see if you know absolute value. Wow. So even though in class, when you do absolute value, you know it. The absolute value minus 3, the absolute value 3, and you go over it and you understand it. But that's not the problem they give you in your exam. So multiplying and dividing decimals, mixed numbers to improper, undefined, this between 2 numbers on the number line, absolute value. What am I missing? Oh, square roots, cube, and cube root. Oh, I forgot one more. Cube and cube root. And then the last one is greatest common factor and least common denominator. This is your first 5. So I hear educators, oh, don't worry about the first 5. You can't, no. You need to worry about the first 5, because the first 5 is basic math. And let me explain something to you. See, this is the analogy I want to use. If I'm starting a race and that person in front of me gets in front of me by 5 yards, I may give up. If you get the first 5 wrong, you will already be getting behind. But if you get those first 5 right, what happens to your confidence? What happens to your self-esteem? I got all them right. Yeah, Mr. Tinsley told me I only need 24 right. I got the first 5 right. So now I only need 19 out of the next 40 problems. That adds to you. So again, that's the first 5. So let's go over our exponent rule, even though Rel, it seemed like he got disconnected. So hopefully he'll join us again. So let's go over these. So I'm gonna save this, that first 5, and then so again, multiplying, dividing decimals, converting mixed numbers to improper fractions or improper fractions to mixed numbers, undefined, the distance between two numbers on a number line, which is absolute value, square roots, cube and cube roots, greatest common factor, and least common denominator. Or least common multiple, I'm sorry, not LCD, LCM, least common multiple. Okay, those are your first 5. You need to know because you will see them. And if you get the first 5 right, you feeling good about yourself. Now, let's go to what Rel was talking about. Oh, he just joined us back. He's back. So let's go over the exponent rules. Again, a guaranteed question, one of your first 5. So those are the others, but also your exponent rules are also one of your first 5. Anything to the 0 power is 1. Doesn't matter what it is. It could be xy to the 0 power. It is 1. Anything to the first power is the base. Doesn't matter. It's a letter or number. Anything to the first power is the base. When you're multiplying exponents, you add the exponents. So the x, remember, x is the base. The 2 and the 3 are the exponents. 2 plus 3 is 5. So the answer to this will be x to the 5th. That easy. Now, they're not going to give it to you that easy. I'm going to show you what type of problem they're going to give you after this. If you're dividing exponents, so remember I told you math is about patterns. Remember I told you 3 times 4 is 12. 12 divided by 4 is 3. Multiplication is the inverse operation of division. Division is the inverse operation of multiplication. So if I'm adding when I'm multiplying, I need to subtract when I'm dividing. So x to the 9th divided by x squared. If I subtract top minus bottom, 9 minus 2 is 7. Because math is about patterns. Okay? If I'm raising to a power, so x to the 3rd to the 2nd power. What does the 2nd power mean? It means I'm multiplying the same number twice. So this is x to the 3rd times x to the 3rd. Well, we know if we multiply exponents with the same base, we're adding exponents. So this is x to the 6th. Remember I told you, math is about patterns. 3 times 2 is 6. So when you raise to a power, you're multiplying the exponents. How Kevin Hart say, if you didn't know, you're going to learn today.
I was telling you, my grandmother's pulled up, dropped my groceries. My bad, bro.
Listen, you don't have to apologize. Life is what it is. Life is what it is. I'm glad you're here. And again, I left for a long time because my dad was sick, but I'm back in the building and I'm ready to help people pass their exam. I'm excited.
It sounded like to me that prayer went up, but that prayer worked for Pop.
He walking. He even asked him to drive his car again. Now he's still doing chemo. We still got some miles to go, but he got no negative effects from the chemo. Man, listen, man, I love it. I'm loving it. Now, let's do negative exponents. So if we had let's say x to the minus 5th, you change the sign of the exponent and switch the orientation. So x to the minus 5th is the same as x to the minus 5th over 1. So 1 over x to the 5th. So change it from top to bottom, change the sign of the exponent. So for example, if I had c to the negative 3rd over d to the negative 5th, my c to the negative 3rd is going to come down the bottom. My exponents become positive. That's negative. So it's on the bottom, it comes to the top. So this is really the same as d to the 5th divided by c to the 3rd. These are your exponent rules. Mr. Tinsley, I understand them. I went over in class. I know how to do it. But guess what? They're not going to give you a question that's this easy. What they're going to do is they're going to give you a problem like this. Let me show you. And then what happens is when you see a problem like this, your head is about to explode. And you start questioning yourself. You start saying, hold on, I've been studying for months and months, and I don't know how to do this problem. Why don't I know how to do this problem? And what I want you to say is, I had Mr. Tinsley too. So Mr. Tinsley said, when I get all worked up, we'll take a couple deep breaths. And you're going to say something positive. I know the exponent rules, and I see a whole lot of exponents. Multiplying exponents, I add the exponents. When I raise something to a power, I multiply the exponents. Watch this. Now, take those deep breaths. What happens is you allow oxygen to pass through your brain. When you doubt yourself and you get frustrated, you cut off oxygen to your brain and rational thought goes out the window. So that's why, if you ever seen Will Smith and Martin Lawrence, when he goes woosah and he pulls his ears, that's a real thing. You take them deep breaths, you bring oxygen to your brain, and then we go and we're gonna say positive things. So I know how these are exponents, right? So since I'm multiplying, that X means multiplying. So what happens is, first, I know, please excuse my dear Aunt Sally. That tells me I don't have anything in parentheses that I can simplify. So I'm done with the parentheses. Right now, even though I have parentheses, but I have nothing in the parentheses I can simplify. So I'll go to the next step. I do have exponents. I have exponents all over the place, but I have something raised to an exponent. So I'm going to do that first. So I'm going to bring my first one down. 2 times 9 times 3 to the 5th. Remember, when you don't see an exponent, it's a 1. Exponent rules tell me when I raise something to a power, I multiply the exponents. So 4 times 2 is 8. 1 times 2 is 2. So I got 2 to the 8th power times 3 to the 2nd power. Oh, Mr. Tinsley told me when you got the same base and you're multiplying, remember, this X means multiplying, this X means multiplying, this X means multiplying. Well, the associative property tells you it doesn't matter what order you multiply, because 3 times 4 is the same as 4 times 3. I remember that because Mr. Tinsley told me. I don't remember what the rules called, but I remember he told me it doesn't matter what order you multiply, it's still the same thing. So 2 to the 9th times 2 to the 8th have the same base. So I need to add those exponents. 9 plus 8. Let me change my color to red so we can see it. 9 plus 8 is 17. So 2 to the 17th power. Now, I figured that out. Only one answer has 2 to the 17th power. I don't have to do anymore. I know my answer. I'm done. And I'm feeling good about myself. Stop. But let's continue. 3 to the 5th times 3 squared. They have the same base, which is 3. The exponents is 5 and 2. When I'm multiplying exponents with the same base, I add 3 to the 7th. Stop playing. Ooh, I am back in the building. You better watch out, because 2024 is going to be a whole lot of people passing this GED exam. I am back.
And this is without the calculator.
Yep. So now, watch this. Watch this. I'm glad you said that, because you can't really use the calculator for this. You can, but you can't, right? But guess what? I had a student. This is what he did. He said, Mr. Tinsley, I couldn't remember what you told me about those exponent rules. But what you did tell me, Mr. Tinsley, said I can find my answers using my calculator. I said, what do you mean by that? He said, once I knew how to use the calculator, I'm trying to find something equivalent. I'm trying to find the same answer. So what I did was I put in my calculator 2 to the 9th times 3 to the 5th times 2 to the 4th times 3 raised to the 2nd power. And I got my answer. I got a crazy answer, Mr. Tinsley. I didn't even know what it meant. But what I did know is whatever my answer was from that multiple choice, I would get the same thing. So I took each of the multiple choice and I said 6 to the 20th. That is not the same problem. I did. So if I know 6 to the 20th is too big, I know 6 to the 24th is even bigger. So I knew it wasn't that, Mr. Tinsley. So then I said 2 to the 13th times 3 to the 7th. And I still didn't get the same answer. I got to the last answer, and I knew that was the last answer, but I wanted to check. So 2 to the 17th times 3 to the 7th. Wow, got the same answer. He didn't know any exponent rules, but what he remembered was Mr. Tinsley told me if I got a multiple choice problem, one of those is the answers. So I keep doing it till I get the same thing. Wow. Ooh. You're gonna learn today. But listen, understand that if you practice with this calculator, if you use my ebook and learn this calculator, I'm telling you, you're gonna have all the shortcuts to be able to pass this exam. Had another person pass today, had another person pass yesterday. I'm going to start posting again. I'm going to start putting my YouTube videos up again. My dad was sick. It knocked me off my square, but I'm back. He's happy. He's laughing. And plus, no matter what happens, my
Mr.
life
Tenzi,
still
did we
yes.
did we post last week's class as well?
I thought I did. I didn't.
And I just wanted to make sure because last week's class I had missed it.
I'm not. I think I thought I did. I may not have. But I'll check. So at 7 o'clock, we're gonna do one more. Again, here it is right here. Numbers on a number line. Distance between two numbers on a number line. For example, on a number line, the points plotted are -2 and 4. Sorry. The distance between the point is 6. How do you know? You just count. 1, 2, 3, 4, 5, 6. Easy. Not hard at all. Mr. Tinsley, that's easy. I know how to do that. This is what we did in class. Mr. Tinsley, I know how to do this problem. 1, 2, 3, 4 minus 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Mr. Tinsley, that's an easy problem. I know how to do that. Unfortunately, that's not what they're going to give you. What they're going to do is they're going to give you this question, but they're going to give you the answers as absolute value. So they're going to say the absolute value of -4 plus 5, or the absolute value of -5 plus 4, or the absolute value of -4 minus 5, or the absolute value of 3. I'm just making that up. What you have to know is the distance between -4 and 5 is 9. You already know that because you know how to count. Everybody knows how to count. But the problem is when they give those multiple choice answers, you got to find the absolute value of these numbers. So 5 minus 4 is 1. So the absolute value of 1 is 1. -5 plus 4. The absolute value of -1 is also 1. But we're looking for 9. The absolute value of -9 is 9. Ding, 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 ding. That's the equivalent. Bam. That's what you're going to see. One of the first 5. Ooh. This is going to be a good 2024. I'm telling you, it's going to be so many people passing this GED exam, and each of you are going to be one of those. Don't even worry, because we're going in and we're thinking positive thoughts. No matter what happens that's good against us, whether it's our job, whether it's our children, what we have to understand is we are the most important person to us. People might come, my mom and dad, my sons, my wife might be a close second, but the most important person to me is me. My mind got to be right. My health got to be right. My heart got to be right. My soul got to be right. Because if all those things is right, I can help everybody else. Stop playing. All right, let me stop because I'm gonna start asking for the pass the plate around. We don't want to do that.
I'm trying to tell you.
I want to kid. But listen, again, I'm back. I'm making sure I'm post this tonight. It's gonna be on YouTube. Tell your friends again. I'm back. I set up. I'm moving my website to a different host. So, but I'm gonna have to send out the weekly ones by hand through my Gmail. They won't go out automatically, but again, I'm going to be inviting people. We putting in the groups again. Because remember, I was having 12 people, 15 people, 18 people, 19 people, but I died down. And what happened because of my? Let me stop the record. Let me pause it.
Yeah.